Alrighty, so I did read through the solution to the problem, and I think the big miss was that actually we need to weave the result of the left and the right sequence, I believe, in. So let me get the book actually. But yeah, that's interesting. Let's give it a shot at just writing weave, and I think this will maybe illustrate something that I failed to internalize. And so what does weave do? Well, weave basically weaves together two sequences it weaves together two sequences, preserving their order, but weaving them every single way that they could be woven, I guess. And so it's definitely a recursive function. But let's see about this. All right, so I'm just gonna start off. But so I think the initial, this just says then weave xs, ys, and the empty sequence, right? That's how they do it with their mutable version. Does that make sense for what we want to do? No. And I'm okay. So anyway, I think this part's right. So let's just focus on this part now. I'm trying to think whether it's better to. No, we definitely need to recurse because we need to split our computation. We need to take off the front of xs and take off the front of ys and put the two together. Well, no. So that's one interesting thing. Is there not really. Okay, let's just see. So again, cond, and I'm pretty sure we're basically saying if and empty xs and empty ys, right? If you're completely empty on both sides, then just return zs, right? That's the thing you want to do. I think that's one of them. But otherwise, wow, it is so hot today. It's ridiculous. I feel like I'm making it hotter in the room just by speaking. All right. XS, YS, ZS, and if that's not the case, I think if empty XS, right? Empty XS, I think the way that sounds. Weave, then we only need to really go down the YS path, right? In fact, we don't even really need to call weave. We can actually just kind of. So assuming xs, ys, and let's assume xs, ys are vectors, right? Oh no. So this is part of my thing, right? Let's assume xs and ys are vectors, that is things we can pop things off easily, and zs is a list, that is things we can cons onto the front easily, right? You can also do this if you want. I kind of like the semi-literal syntax, right? So, if that's the case, then if we have an empty XS, then I think all we need to do is just put the end of YS onto XS, right? So the front of YS onto XS. Man, how do they do this algorithm with their data structures? Oh, it's so complicated to read. I mean, this is a 60-line solution. Am I really supposed to be able to write one line every 45 seconds of code? I mean, that just seems absurd at first. Whatever. I mean, anyway. Empty excess. So, if excess is empty, then we don't need to do anything with it, right? We need to basically, I'm not quite clear whether we need to put things onto or take things off of ZS. The ZS is the prefix, right? And so we're going to be, yeah, we're going to be adding things onto the end of prefix. Actually, never mind. They're all vectors, right? Man, so hot. All right. Let me get the fan. Okay. All right. If excess is empty, then all we need to do is, I think we just need to into ZS all of, well, we don't want all of excess. We kind of want the, I guess what we want is the excess. No, we do want all, yeah, into ZS all of YS, right? That's all we can do. But if YS is empty, we want to into ZS all of excess, right? And now we know it's not empty, and we know there's two of them. So that means we want to let me just think about how this is. This isn't a, yeah, it's taking the items off the, there's a mistake here. Well, there's not a mistake, but okay. Anyway, there's a, like, this makes it a little bit uglier thing. Yeah, what are they using for their data structure? They have an array list. And they're making a new array list within each double for loop. Okay. Anyway, let's not worry about performance here. Let's just, so x and x rest, right, is equal to xs, and y and y rest equal to ys, right? And then, okay, we know there is an x and there is a y, and that we need to put them on both ends, right? But we need to put them together, right? But we need to call now. We don't really actually want to use this. You know, because we keep taking off the front of these lists, maybe it's actually the case that we want these to be list and this to be a vector. Because we want to basically push onto the end of this thing, and we generally want to take off the front of these things, right? Yeah, okay. So we don't need to actually convert it here. It might be a good idea just for consistency, but it's fine because they're not doing anything. Well, wait, into ZS. Into on a list will do a different thing. Oh, but that's ZS, that's not. YS will, take off the front and put them onto the end of ZS. So I think that's what we expect. Okay. ZS will definitely return a vector. X and X rest Y and Y. Okay, that's actually pretty much all we need. So what we need to do is we're going to pick one of them. Right? We're going to weave XS and the conj of zs and x. Whoops, and all right, let's talk about for something like that for both of them, right? No, that's the whole point. We don't have to do the concatenate thing. We're just gonna keep splitting. But if we split, it's gonna each of these calls is gonna return at least each of this one is going to return at least 2 items. Okay, we'll worry about that in a second, but it's definitely got to go down 2 paths too, right? Yeah, I mean, it's got to go down the path of I'm picking this time. I'm not going. This time, what my goal is to get to the very end where xs and ys are both empty. So we need to go down one where I've conged x onto zs, right? And if I've done that, then I've taken the rest of x. So I'm going to do that. And we need to go down one where I've conged y onto zs, right? Oops. And I'm talking about leaving the excess alone. Oh wait, sorry, that's just wrong. Should keep the order, it just, oh. It should keep the order, it should just, yeah. So you're taking off of x, and you're gonna pass in x rest recursively. You're gonna conj x onto zs. You're passing in you're leaving xs alone. You're gonna leave the rest of y to this guy, and you're conjing y onto zs. You now have split down the 2 different ways, I think, to weave this. We still need to kind of, I keep thinking we have to put them together, but we don't. I mean, like maybe, this is a pattern I've never done. I always try to return the sequence, but maybe, well, I really do feel weird about having an accumulator that's literally just going to be used to return all the results. But I kind of would feel like it would make it easier, because then I just need to basically just run through all the whole path, and then just every time you see this event occur, right, which is not correct. This should be ZS here. Every time you see this occur, add it into this accumulator thing, which you could have like right here, right? Right? It's like an atom too, So it can be mutably changed throughout the execution of this thing, right? There's just going to be all the solutions we found, right? I mean, we could do that, but I don't think it's ever a reason to need to do that for I think you can always write it in a way that it will put things together. I do think it may make it a bit weirder. Let's try without first, and then if we can't figure it out, we'll do with. But okay, this guy is clearly returning 2 elements. So we gotta basically put, like, there's no choice. We just have to put it into a collection, And I'm pretty sure we've seen this before. If that's true, we need to concatenate it so that, no, we don't really. I mean, do we? No, let's just start with this. This guy's returning a collection, but that means these guys need to return collections too. This guy's not currently returning a collection. He's just returning an array, so let's just put him in a collection. This guy's not returning a collection. He's just returning an array, so let's put him in a collection. This guy's not returning a collection. He's just returning an array, so let's put him in a collection. All right, so now everybody's returning a collection. All right, 3 of the cases return 1-element collections. This case will return these are definitely 3 cases are definitely 1-element collections, but this one is actually 2 collections of collections. So I'm pretty sure this is the one that we want to concat, right? Because we want to sort of, like, this is going to be, I mean, because weave always returns a collection, right? This is going to be a collection of collections, right? And so we're going to make it into this concat is basically going to remove this. Okay, do we need to apply, or can we just do this? I always do that, but then maybe we can just do this. Maybe that's what I needed to do. No, because that was a for loop, so there's really no choice. Oh my gosh, but that was a... Oh, I don't know. Concat. This should return a collection of arrays. Weave. Let's give it a name. Every kind of a terrible description, but this guy returns collection, collection, collection. This guy returns a collection of... This guy returns a collection, right? But if we concat them all together, they become a singular collection. Counter present even number of forms. Okay, yeah, sure. Express. Alright, not worried about that for the moment. There's a lot. Alright. T/R. So sure. Okay, so we're looking for expected is equal to the weave of xs and ys. And we're looking for things like the empty list plus the empty list should return the empty list. I call weave with 3 arguments. Okay, well, that's weird. Where is that going from? I call weave with 3 arguments. It seems hard to believe. Oh, you're right. I left the accumulator in there, which I don't think we may need. And I think you're actually right. This is the array that makes this sequence. Okay. Let's talk about just one and empty. Here's this. Excuse me. Let's talk about 1 and 1 should just return this. Let's talk about 1 and 2 should return 1, 2. It should also return 2, 1. Oh. Lame. Alright, well that probably means we entered into this guy for the first time. Oops, I meant... Let's put this guy closer. Whoa. I guess that was the very slow way to do that. Alright, Alright, your guess is as good as mine, so I'll stand by. String. We started with 3 empty. Oh, it's doing the other ones. Okay. We started with 1, 2 in the empty array, or 1, 2 and empty. Wait, I thought we were gonna. Well, I guess we were going to make them into lists, and they're going to be used as lists in most ways, but they actually are not lists on the very first iteration. Anyway, okay. And you got a problem with that. So you're saying something about that does not, do not like. Empty XS, empty YS, ZS. Can't be this, really. It can't be this. I don't think it can be any of these top 3. I think it has to be in here. So you got X and XS, Y and YS. Oh, I see what we did. It's just dumb. Okay. Okay. But you do need to... Okay. That's interesting. And this is how you use that better. I wonder if I could have just concated that. No, because you only have one lazy sequence from a for loop. It's just... Yeah, okay, I think I get why we could do this here, but not there. Alright, so that's weave. Or, no, sorry, we're not even close to that point yet. Let's look at more complicated things. Okay. So what should we get out of this? Well, we should get a 1, 2, 3, 4. We should get a 1, 2. We should get a 1, 3, 4, 2. We should get a 3, 1, 2, 4. 3, 1, 2, 4. And we should get a 3, 3, 1, 4, 2. And we should get a 3, 4, 1, 2. If you're curious how I did that so quickly, I copied it from the book. Alright. 1, 2, 3, 4. Just see that makes kind of sense. So you just add 1, 2, and you add 3, 4 to the end of it. That means 1, 3, 2, 4. It means you did 1, 3, 2, 4. That makes sense. 1, 3, 4, 2. 1, then 3, then 4, then 2. 3, 1, 2, 4. You started at 3. Then you went 1, 2, 4. You started at 3. Then you went 1, and then you went back to 4, then you went to 2. You started at 3, and then you went to 4, and you went to 1, 2. Interesting. Okay, well, I feel better about weave than I do about our BST sequence function. But then, like, potentially, weave might just be a matter of calling weave with this. Let's see. Do we still need to do the for loop? I think so. but now I'm kind of thinking we don't need to do the apply on the concat. Let's see. Unfortunately, we're still failing, but. And let's get the weave out. Oddly enough, we're only failing one thing here. Which maybe because I brute forced these, maybe, or I just tried to guess them all. Maybe I'm wrong. So we have 3, 4, 5, 2, 1. 3, 4, 5, 2, 1. Yeah, we got that one. 3, 2, 1, 4, 5. 3, 2, 1, 4, 5. Yep, I got that one. We got 3, 4, 2, 1, 5. 3, 4, 2, 1, 5. I got that one. I got 3, 2, 4, 1, 5. I got 3, 2, 4, 1, 5. Oh, but I also got 3, 2, 4, 5, 1. And still not quite there. We're missing one. Okay, which one am I missing? 3, 4, 2, 5, 1. Yes. Got it. 3, 2, 1, 4, 5. Yes, got it. 3, 4, 2, 1, 5. 3, 4, 2, yep. 3, 2, 4, 5, 1. Maybe that's it. Yeah. Nope, that's the one I just added. 3, 2, 4, 1, 5. 3, 2, 4. Yep, got that one. 3, 4, 5, 2, 1. 3, 4, 5. Well, wait a minute. 1, 2, 3, 4, 5, 6. Which one am I missing? Wait, I said 3, 2, 4, 1, 5, but I don't see it. I see 3, 2, 4, 5, 1, but I don't see 3, 2, 4, 1, 5. God damn it, it's right there. Okay. Alright, this is dumb. 3, 4, 2, 5, 1. That's what it's missing. It's just the numbers are so similar, it's hard to. 3, 4, 2, 5, 1. There you go. Well, that may be it then, right? I'm actually a little surprised we didn't have to remove the concat, because I'm just a little confused by this, actually. No, it definitely doesn't work, so don't do that. But so 4 returns a lazy sequence of weaves. Weaves are a sequence of arrays, let's say, you know. So it's a sequence of arrays, and we just convert it into a sequence of arrays with this 4. Which is the signature of sequence of arrays of this function. We said we were going to do something, which is actually, I was saying this might not be the worst idea. The return value should be a sequence, right? I think kind of sucks about this thing right here is that it doesn't tell you what it was, right? It just tells you that it failed. Cannot resolve symbol sequence. Whew. So hot in here. Sequence. Oh, maybe it's just seek? Question mark. Sure. Those aren't entirely the same thing. I know there's a distinction, but I don't remember exactly what they are. But I think this is close enough. Seek return, right? And it's not return, it's this. We're also going to say that every element in the return needs to be a number, right? Every element in the return sequence needs to be a number. So it needs to always be a sequence of numbers is what this needs to be. resolve symbol number. Okay, limit. Yeah, and so that way, if I start doing silly things like this, it should actually blow up at every function. Yeah, the thing that I don't like about that is I really wish it would print out what it was, you know? Like the fact that it just tells me it failed is useful, but not crazy useful. I mean, you can end up doing it, I guess, by saying, no, I mean, you can guess how to do this, right? It's just like do, and then, or let. Something like this you could do, you know. Nope, nope, nope. Done with that, and we're just gonna return. Oh, we fixed it, but if we break it again, you know, I mean, you can do that. You know, I don't know. To me, it's just such a overly complicated syntax that I kind of feel like we should fix this so that this not only throws an assertion, but the assertion contains useful information. You know, like what was the value that failed? You know. So anyway, but I think that's a little bit overkill for here. Let's just focus on this one. All right. And I mean this right here, right? It printed out the result right there in terms of what failed. So you can see, oh, the 2 is not an array, you know? And you're like, okay, I get it, you know? That's what's wrong. So they're like, okay, well, this has off by 1, and you do this, yeah. So I think that's the actual solution for the problem, I think, you know? And yeah, the big failure was one, you know, spending too much time on kind of just getting the concat stuff to work correctly, you know. I don't feel that but 2 was the realization that this is easier if you just split it into 2 problems, 2 recursive functions, you know, rather than trying to do everything in one recursive function. I think this is a really expensive function. I think it's like, I don't know, like 2n. I mean, each of these is 2n, right? For the length of the shorter array, where n is the length of the shorter array, right? And then, when I say 2n, I mean 2 raised to the n, right? Right, where the n is the length of the shorter array, I think. And then, furthermore, you're doing that on every recursive split here. Right, so that's like 2n within here. Then it's also like, I mean, this is also splitting whenever you have 2 children, right? So yeah, I do not think this is an efficient algorithm at all. I mean, this is, yeah, so it's actually, I think it's 2n times n squared, maybe? Because you're taking the left sequence and the right sequence. I'm kind of curious if you really... Like, actually, I kind of want to see how many results there are. That kind of makes me think we're overdoing it by quite a margin. So you got the last 2, because they'll be incredibly large, but... Whoa, not at all. Uh-huh. Let's just print out exactly when it recurses. Something pretty similar to this guy, at least. And what else? We want to print out, I guess that's it, really. Oh, we need CS doesn't exist. We want the, fortunately we don't have an accumulator anymore, so there's nothing cool to increase upon. We'd have to actually add something to make it accumulate well. For now, let's just do this. I just want to see how many calls does it end up doing. So it did 3. That seems like the correct number. But what about this one? This did 2. That seems reasonable. What about this one? Did 3. That seems reasonable. Actually, did a pretty minimal number of BST sequences. So to be fair, every time it does one of those things, it has to do the weave thing, which is a log, which is a 2n algorithm, right? Let's just see how bad it gets, how quickly. Really, wow. Really doesn't overshoot. I guess it doesn't overshoot much at all, it seems like. Oh dear. I actually forgot what I did to make it break. Oh, I took out stat, that's right, that's all. Cool. All right, I think that's that one. Fortunately, was not able to solve it on my own. Had to read the book, but anyway, yeah, that's good. Yeah, biggest learnings is probably if you're having trouble getting this stuff to concat out and everything, probably add something like this at the top so that you don't have to keep screwing it up. It's going to tell you the moment you screw it up, right? You could also do something similar for the pre's if you want to just make sure that a node is shaped the right way, which there's not a whole lot of rules. It's a 1 to 3 element thing where the first element must be specified and the second and third element must either be a value or yeah, I think that's actually about it. The first element must be specified. I guess if the third element is nil, the third element cannot be nil if the second element is, the third element cannot be nil, period, and the second element may only be nil if the third element has a value. I think that's about all the rules for what is a valid tree here. And what else? I think that's all I can really say about it. It was also to do 2 separate recursive functions here, which I think we sort of, I don't know if we knew it was going to be 2 recursive functions, but I knew that the issue was down here, right? But I didn't know exactly how to, I don't think I ever used the word weave them together, but I didn't know how to weave them together, basically, the way they needed to be woven. I think the algorithm is fundamentally n squared. The 2n, or sorry, 2n, actually, sorry, yeah. I think it's actually n squared times 2n. I think it's n squared because it does the for loop within the for loop, right? So n by n. And I think it's 2n because the weave is basically 2n, as near as I can tell, on the on this, right? It's basically just taking one element off one side, and yeah, you're going to have to basically split the work every single time. So that's probably 2n. So n squared times 2n. When I say 2n, I mean 2 raised to the n. N squared times 2 raised to the n is just 2 raised to the n. So not a great algorithm at all. But is it the minimal it could be? How do you weave something without spending the time weaving it? That's the question, I guess. Maybe? I don't. I just. Yeah, I can't think of anything better. But that doesn't mean a whole lot, honestly. I guess we'll take this one out now. This is my initial implementation. And if we wanted to, we could also combine these two into one. Sure, let's do it, yeah. I guess the pre and the post conditions go after the function argument. I guess that makes sense, but yeah, I guess that makes sense because the function arguments could be after. I mean, the return value of different arity functions could be entirely different, so it doesn't make sense to have them all be, the pre and the post be the same for all functions. Node. Oh wait, we can't do this. There's no distinction between the two of them. In fact, there is no distinction between the two of them. Why don't we just put them together? We previously were adding an accumulator, but now we're not even doing that. So. BST sequence recursive just becomes BST sequence. Could not resolve simple node. I think that's because we called it nit on this one. Okay. That's, oh crap, did I delete my comment? What was my comment? Node, same thing again. Alright. That's, that's pretty decent. I guess it's not just this node, but this this BST. Yeah, I'm embarrassed to say that. I mean, I guess what is the advantage here? Is 35 lines a whole lot better than 60 lines? Not really, Does this implementation have any advantages for their implementation? The one I would say is that you do have a lazy sequence here. So I think potentially you could actually take a subset of them, you know. I'm actually curious to see what order does it generally expel them in. Wait, it still made a set out of it. Oh, that's my set, yeah. 3 2 1 4 3 2 4 1 3 4 2 1, starting with yeah. So it looks like it goes maybe depth first, search down first, right? Which maybe isn't surprising, right? Let's see. 3 2 1 4 3 2 4 1 3 2 4 5. Yeah, I think it does a depth first search of the solutions here. All right, I think. And just kind of like a big duh, but I mean, so you know, there could be some advantage, like give me the first BST sequence that could give me this. That could give me this result, you know. And I think I'm not entirely sure exactly where. I think that the fact that this is a lazy, even though you are, yeah. I mean, you know, there's nothing about it, yeah. I think this could mean that you're basically only calculating these as you need them. I guess we can sort of figure that out if that's true by just like take 5 on them, you know. Of course, then we need to print it out too. So we'll just print it out. Number of calls to BST sequence. All right, that should make it kind of obvious. And yeah, we got too much data here. So let's just pop this off and close all of these. Okay, so it ends up doing 1, 2, 3, 4, 5. That's a bit surprising since we actually. Well, I guess yeah. Maybe it's not. But I think if we maybe just take 2 out of this, we might get fewer sequences. Let's see. Let's just try taking 1. Nah, you still do all of them. So something about this is pushing evaluation forward, and I think it's the apply. Which I don't 100% get the apply. Why that has to happen. Oh wait, should this... Oh well. So I don't really feel there's any real advantage. Well, I mean, other than familiarity for me, you know. It's about half the number of lines, but yeah, I just don't quite see why. I mean, this is a lazy sequence, so it's definitely only doing the left BST sequence and the right BST. Oh, but I guess to build the BST sequence, it does need to make the recursive calls, but then to weave them, that's an interesting question, yeah. Will the number of weaves change if we reduce it? Okay, so for this one we needed a total of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 weaves. Let's just try taking 1. No difference. Yeah, I'm not clear about that. Something about this forces evaluation, but I can't tell you what it is. There's a lot of lazy things in here. There's, you know, for loops. There's the map of the, I guess the apply of the concat. I get that forces. I get that you know, concatenate or the does that. But does that mean that the for loop must be evaluated? Can't it just? Well, I guess. Um, hmm. And how would we make this lazy? I'm just to sanity check myself here. I'm gonna actually just do this and see what happens. Yeah, we definitely got problems. Yeah. Just a sanity check again. Yeah. Okay. So it's something about that, but I do feel like it should be possible. I think it's the application of concat that causes us to need to evaluate each of these. But I mean, there's no reason to need to evaluate the subsequent one if you just needed the first one, right? And so I like it must be possible to make this lazy, you know. Um, anyway, we are getting way too much time on this one, so. And okay, MGS. Oh crap, that was not right. Well, I guess it technically was. I don't know what I'll do on that. If you, I think I'm gonna try to amend it. What do you call those Russian dolls? Anyway, uh, ugh, it's too bad. All right, I'll take a little break.